So we're starting off at a couple homework problems on page 240, number 24. Give me a little bit of space. Okay, so on 240, number 24, it's pretty ugly looking, but this is totally a question I would ask on a test. So page 240, number 24 says u plus v over u minus v minus u minus v over u plus v over u plus v over u minus v plus u minus v over u plus v. Now, if you really stop and think about it and do exactly what they tell you with PEMDAS, because the question said to simplify, that's order of operations. And if I'm thinking order of operations on this simplify, which is PEMDAS, what would I be wanting to do first? And is there a parentheses in here? Kind of is. Parentheses groups things, right? And this division sign is grouping the top part together and then the bottom part together. So this division right here, even though it's D for division, it really is separating this like parentheses do. So if I wanted to, I could just straight up subtract these two numbers. But this is not an equation, is it? So because it's not an equation, I would be forced to find a common denominator there, readjust the numerators, and then subtract them through a lot of foiling and a lot of junk. And I could do that. And then I could come down here to the bottom and do the same kind of thing. And that'd be fine. And then once I get the top all together and the bottom all together, how do I take, that would be one fraction there and one fraction there. How do I divide a fraction by a fraction? Multiply by the reciprocal. You can totally do that if you want, but I gave you a hint, a trick. I said if you ever have a fraction, which I do, with another fraction inside of it, one or more, what was the trick I told you? And I told you this sometime last week. I said you could multiply each term by a common denominator of this whole problem. And basically that's multiplying the top and the bottom. And I'm allowed to multiply the top and the bottom of an expression because that doesn't change the value, does it? That's like multiplying by the number 1. So what if I multiply, by the way, what is the common denominator of all four of these fractions? So I'm going to multiply the top by a u plus v, u minus v. And I'm going to multiply the bottom by a u plus v, u minus v. And what I'm really doing is multiplying by the fraction 1. Now I don't really have room to distribute that in, but I'm going to show it. If I take both of these right here and distribute it into each part, and take both of these and distribute it into each part, tell me, what do I get when I take this fraction times that? What cancels? The u minus v's, and I'm left with u plus v squared. Bring down the negative. When I multiply that fraction by that, what do I get? U minus v squared. And on the bottom, when I multiply that times this, what do I get? U plus v again squared. And then that times that, what do I get? U minus v squared. Now, I don't know about you, but to me that already looks better. And now my fraction within a fraction is gone. I'm going to do that all night and day on this test. I mean, you go look at this question, this review, and there's tons of problems where you have fractions inside fractions. Maybe not tons, but there are a number. All right, now, I'm still trying to simplify, right? So simplify means PEMDAS, so don't factor it. I know it looks like a difference of 2 squares there, which makes you want to factor, but no F in PEMDAS for factoring, is there? So what would you do if you wanted to simplify this at this point? Move on to exponents. So multiply all these out and then add and subtract, multiply, divide, all that stuff. Let's just start doing it. So what does this give me when I square that? U squared plus 2uv plus v squared. What does this thing give me? u squared minus 2uv plus v squared. Do you see why I left it in parentheses? Because I'm going to have to distribute that negative in. That's probably the biggest mistake on a problem like this that I see. And then on the bottom, same thing, u squared plus 2uv plus v squared, except this time it's plus, so I really don't need to put it in parentheses, but I can. But there's nothing that's going to be multiplied in there. So I tend to like to cheat a little bit I don't want to rewrite this whole thing again. So this negative is just going to change all these signs. Right, so that's going to become a negative u squared, a positive uv, and a negative v squared. But this positive doesn't do anything. And at this point, I'm going to just clean it all up. So what do I end up with on the top? U squareds cancel.
4uv.
V squareds cancel. 4uv. What do I end up with on the bottom? 2uv's cancel, right? And 2u squared plus 2v squared. Is there anything right here that I could do with this? Now, why would I bother factoring if it says PEMDAS and there's no F in PEMDAS? You're right, but why would I do that? Because it's going to help me. Yeah, sometimes when I factor, something will cancel. And I can see that if I do factor 2 out, I can cancel that 2 with that 4. So I am going to factor that 2 out. And then now that 4 will cancel with that. I'm sorry, that 2 and the 4, I can cancel the 2 out. So 2uv over u squared plus v squared. That's a lot going on in a problem like that, but definitely something we should know how to do. And I bet that's going to show up somewhere in one of these. So that's number 24. Let's jump to page 249 and 50. And let's look at 18 and then at 30. Has everybody got that needs it? All right, so 249, 50, 18, 1 over x plus 1, minus 1 over x plus 2.
Wait, no, it's the word problem. So on page 250.
Oh, number 18. Okay. So, page 250. Word problem. All right, so number 18 on, it's actually 251, sorry. So on 251. So the word problem on 251 said, because of traffic, you're gonna have to read this along if you're at home. Maria could average only 40 kilometers an hour for the first 20% of her trip. To me, that's kind of misleading because you see average rate and you think, oh, it's the average rate. But it really is just the rate. The first 20% of her trip, the first 20% of the distance traveled, the rate was 40 km. So I'm going to write the first rate is 40, and the distance is 0.2 of the total distance. Does that make sense? I don't know what the total distance is. They didn't tell me. So if it was 100 miles, it would be 20 of it. If it was 1,000, it would be 200. I don't know, but it's 0.2 of the total. That's the first distance. And I'm going to see what, I may not even need that. We'll see. Then it says she averaged 75 for the entire trip. That's the average rate. So the average rate was 75 kilometers, and that's for the total distance, which is the total distance. So all I know about the second rate is nothing, but I do know that the second distance would be what? 80% of the total. So I'm just writing out junk I know. It says, what was her average speed for the last 80%? So basically, what was her rate for the last part of the trip? So I don't like that they used average there because it's misleading. But honestly, if I say your rate was for the last 80%, you probably really didn't like put it on cruise control for that whole time. I mean, if you've driven at all, you may not have at this point in your life. But if you have, there's always some slow guy that pulls in front of you and you have to get off your cruise control and then reset it or whatever, or maybe that, you know, I don't know. There's always reasons. So evidently, they might not have done that the whole time, these speeds, but they did it for the most part. They kind of averaged that over that period. So anyway, how am I going to find this? Well, what three things, I mentioned it yesterday in the video, but what things do I personally always write down, because I'm not a big table chart fan. Some of you might be, and if it works for you, great. But if you're not, what three things do I usually suggest?
Distance equals rate times time.
So distance equals rate times time, and along with that,
Rate equals time equals distance. Time equals
rate equals distance over time.
Time equals distance over rate.
So I have those three things if I need them, and then what were the other two things I mentioned? Total distance is sum of the individuals, and total time is sum of the individual times. Now when you start looking at this, definitely this works. D1 plus D2 is total distance. 0.2 dt plus 0.8 dt equals 1 dt. But that doesn't help me solve for r, does it? So the question is, and I've got all this rate stuff, but I don't know anything about times. I don't know anything directly about times. But can I make substitutions? Like, what does each of these d values really mean? RT. So total distance is, if I take this, that's RT. D1 is RT. D2 is RT. This would be average rate, total time. You see how I made substitutions with each d value because d is RT? Here's the problem. I still don't know anything about times, do I? I don't have any information about time. So I don't think this is going to help me, because I just have too many missing pieces of information. But what about this one? I still don't know about times, but what does each of these times mean? D over R? So what if I said, okay, D over R, D over R, D over R, this would be R1, R2, D1, D2, total distance, average rate. Now it's money. Because I know all three distances. Now you may go, no you don't. You still have variables. Okay, we'll be patient with that. And I know two of the three rates, don't I? So let's check this out. The total distance is the total distance. Average rate, 75. Here, D1 is 0.2 times the total. First rate's 40. D2 is 0.8 times the total. R2 is what I'm looking for. Now, can you solve an equation with two variables and one equation? You can't. But can anybody see what I could do here with the dt? Because
you can just make it one.
I could plug anything I want to in there. Like if dt is over here and over here, I could divide all three parts by total distance and it divides away. It's the same variable, isn't it? And I'm not solving for dt. I don't care about it, honestly. Right here, if I divided that side and that side by dt, wouldn't they all cancel? So I'm just going to cancel them out, and I get 1 over 75 equals 0.2 over 40 plus 0.8 over R2. And by the way, if you want, and I know a lot of people who really like this, but if you want, whenever you see dt on all three parts like this, if you ever do see it, then you can plug anything you want there in there for it. Like, so if I wanted to, I could say, you know what, I really don't like these decimals. What if I plugged a 10 there and a 10 there and a 10 there? Then I'd have 10, 2, 8. That's fine. You could plug a 1 there and a 0.2 and a 0.8. You could plug 100 there and a 20 and an 80. Because evidently it doesn't matter what the distance is, it's going to be proportional in this way because they both have dt on both sides. Y'all seeing that? Can you solve it from here? Again, I'm not a big fan of that 0.2, so I'm going to multiply by 10, 10, 10. And if I want, at this point, I can even cancel some stuff to make a smaller common denominator. Maybe I can cancel a 5 out, cancel a 2 out. So if I had 2 over 15 equals 1 over 20 plus 8 over R2, what would you do to solve this? Anybody? Hello? What would would you do to solve that?
Multiply
By the LCM, which is, do you see it?
120.
60 what?
Oh, 60.
60R or 60R2. So multiply by 60R2, clean it all up, and you'll get there. Okay, number 24.
It'd be,
Oh, sorry, number 30. And I don't, oh no!
nice. Nice one.
Remember what it was?
That was like 8 problems.
14, 15.
Can you see him? The shadow?
Ish.
Oh.
Y'all see it?
23, 26, 27, 28.
I don't see it. No way.
That's a 15. Nice. Okay. You can kind of see the little haze right there.
I don't see
That
it.
one's trickier because there's just noise, but I can see the 1.5. Okay. I want to go back through that again. All right, so 251, we're looking at number 30. Is that right? Was it the work problem? Okay, no, you're talking about number 30 on, it's actually still page 250, but not the word problem. And it looks like this, 1 over x minus x over 2 in parentheses, 2 over x minus x equals, and then I'll erase the rest of this 1/2. So pretend you saw that question on your test. All right? It says solve. So if it's solve, if you wanted to, you can multiply both sides by some number that would cancel out fractions, right? But can you even tell what that is yet?
No.
Because you haven't foiled it all out yet. So if it were me, because like right here, if I say, oh, I want to get rid of the x and the 2, I'm going to multiply by 2x. Because there's not a plus there, I'm not going to be able to distribute it. I would just be able to distribute it into one of them. And then there's still an x left over. I don't like to look at it like this. So I'm going to FOIL it out, and then I'm more comfortable. So if I FOIL this out, I get what? 2 over x squared minus 1 minus another 1 plus an x squared over 2. And so I like that a lot better. And if you don't like it, you could always clean it up a little bit. Or you could even add the 2 over there and clean it up even more. I'd probably do that, right? Add 2 to both sides, and you get 5 halves. Right? Now I like it better. So what could you multiply both sides by to clean this all up? 2x squared. So 2x squared on the left side, 2x squared on the right side. Don't forget to distribute it in. But guys, when you see something that looks different, make it look better for you before you start using some rules or whatever. So right here, the x squareds would cancel, leaving me a 4. Here the 2's cancel, leaving me a what? X to the 4th. That's a little odd. And here the 2's cancel, leaving me a 5x squared. So you tell me, what would you do at this point? So get everything that's set equal to 0. I have to subtract that 5x squared. And then once it's set equal to 0, can you factor that? So if it's a trinomial, it's only going to factor into 2 binomials, and that's even if it does factor. But look, this works. X squared, 4 and 1. If they're both negative, that works for me. And then sure enough, this factors even more, doesn't it? So x plus 1, x minus 1, x plus 2, x minus 2. So when you're all said and done, you've got positive 1, negative 1, positive 2, negative 2. Do all of those answers work?
No.
They don't?
You have to check with their name.
Okay, so what in your domain of this problem, what are the only things that can't work? What can x not be? Get up here.
2. Wait.
I only get in trouble when x is what? 0, so I'm fine. But if that had been like an x minus 2 in the bottom, yeah, don't look at x minus, don't look at that. But just look at that x is the denominator. So 0 is the only thing that didn't get me in trouble. So I'm good. All right, let's jump to the actual work. Number 14 on this review. Well, we just did a problem like number 14, didn't we?
Yeah.
In fact, it was even uglier than that. So on this one, well, actually, no, it's not uglier than this. This one actually looks a little better, but it's not actually that much better. I got a fraction within a fraction. What might be a good thing I could do? Multiply the what? The top and the bottom by the common denominator of all four parts. What would be that common denominator here? What is that LCM there?
A plus B times A minus B times.
So A plus B times A minus B times B. Now, I don't really know that this is going to be a whole lot better. I don't, than actually finding a common denominator. So if you ever look at that and you go, man, if I do the top and the bottom by B, A plus B, A minus B, you make the judge of it. I mean, you be the judge of it. If I were to do that, man, I'm dying to get rid of these. 14, 15, 23, 26, 27. If you see that it's not going to make it pretty, then don't do it. Go back to a common denominator. So right here, what would cancel if I distribute that in? Just the b's? And what am I going to have left?
It'd be A times A plus B plus A minus B.
That's a lot. It's okay, let's just leave it for now. And then when I distribute, that's that into there. When I distribute it into here, what do I have? The A plus b's cancel? But what do I have left?
A minus B squared.
And a b. Okay, I'm going to stick with it for a little while. It's the top part kind of squared away. Still pretty awful. What about on the bottom? If I distribute that in, b's cancel. So you still have an A plus B, A minus B. Now the upside to this is I've already done that math. I'm already going to end up doing that math on the top. I can just copy it down to the bottom. So that part will be okay. And then bring down the plus. And then this times this part. Again, B, but this time A plus B squared. Now that's a great start. You would get credit for some of that, but if the problem says to simplify, what do I need to keep doing? PEMDAS. So if I got a PEMDAS, let's just get busy. What would you do here? Are you going to multiply the A in or multiply these first?
Multiply
I'd probably do those first. That gives me an A squared minus a B squared times A. So what does that give me on that top part? A cubed minus AB squared. We good? All right, what about over here? A minus B squared. A squared minus 2AB plus B squared. But then I got to distribute the negative B in. This is really tedious, I know. So negative A squared B positive 2AB squared negative B cubed. Ugh, nasty. And on the bottom, same thing as this, right? So because that and that match, I'm just going to copy down this part and save myself the trouble of doing the math again. But this I'm going to have to do. So that is A squared plus 2AB plus B squared. So I'm going to multiply that B in. So plus A squared B plus 2AB squared plus B cubed. Now does anything clean up here?
Yeah.
So I can add what? Those two things together? And that's it?
On the bottom. Yeah.
On the bottom? So I get A cubed minus A squared B plus AB squared minus B cubed. Oh, this is 30. You're not going to probably get something this involved on a test, but I'll show you what I say. And then this, A cubed. And then what happens here? A squared B, A squared B. That and that becomes a plus AB squared plus B cubed. Oh, actually, you know what? Unless I've made a careless error,
Like,
I
I think it's supposed to be A cubed plus A squared B plus AB squared plus B cubed on the bottom.
Oh, sorry, I miscopied that. So that and that, sorry, I got an AB squared.
So you just like, yeah.
No, I didn't do the math wrong. I mean, that number was wrong, but yeah, but
Hold on.
I actually did the math right. Are y'all with me? Y'all see a mistake on this? This part's the same as that part, so I can put that down. And then this is a squared b, ab squared, 2ab squared plus b cubed.
Well, it would be, oh, wait. Oh, yeah, I think that's it.
I think that's right.
Yeah.
Okay? So this part still cancels, this part becomes a positive ab squared. So here's the thing, I was looking at that and thinking, oh, this is gonna be nasty because you're gonna have to factor a 4-term polynomial. Why don't I have to? Because it says simplify, and is this factoring gonna help me? It would only help me if the bottom part factored, right? But the bottom part doesn't factor. So if the bottom part doesn't factor, because that's a cube, right? So if that bottom part doesn't factor, then I don't have to worry about factoring the top part because nothing's going to cancel anyway. So it's possible I did something like this, but more than likely not. All right, 15. Let's take a look at 15. People freak out on 15. They go, wait a minute. How do I know what the denominator is? You got a fraction inside of a fraction inside of another fraction. Okay, now that may be beyond our pay grade. So let's just think again. If this says simplify, and simplify means PEMDAS, don't these big division signs divide it up? And does it, this fraction inside of a fraction, kind of mean, hey, all of that goes together also? So let's look at just that part first. Let's make this fit our narrative. So if I'm just looking at that and ignore the rest of it for now, what could you do to simplify this part? Hypothetically, pretend that all the rest, just zone in on this. If I have a fraction inside of a fraction, what can I do to help myself out here? What could you do? Find the common denominator of everything, which is x. Multiply the top and the bottom by x. So here's what I'm going to do. I'm going to multiply the top and the bottom by x right here, and I'm going to ignore all the rest of it. So check this out. I'm going to distribute that x in. I'm going to show you don't have to do this. And I'm going to copy everything else back down, and nothing else is going to change except this one part. So what's the x times the 2?
2x.
What's the x times the 1 over x? Minus 1, and x times the regular x, x squared. And now what do I see? Now it looks better already. Now let's just say you look at this and you're like, Mr. Hurry, I do not even, you're blowing my mind here, I don't know what you're doing. Well then again, ignore what I just did and do this. What do I do? Just go to this part right here. How could I add 2 and a negative x? Like what can I do to add just a regular 2 and a minus 1x? Couldn't I find a common denominator? And wouldn't that give me 2x minus 1 over x over another x? And then what do? To divide by a number, I multiply by what? Its reciprocal. And that gives me 2x minus 1 over x squared. Boom. So if you want to do it that way, do it that way. But if you want to use this trick we have, great. But remember, don't get confused when there's more than one thing going on, and you're like, wait a minute, he said fractions within fractions, I could do this. What about a fraction within another fraction? That kind of blows my mind. So let's not do that. Let's just stick to what we know. Look at that inner part and do fraction within a fraction. Let's adjust it. Now it looks better. So now, right now, what can I do? See, now I have a fraction within a fraction. So what can I multiply the top and the bottom by? Yeah, because 1 x squared, common denominator, would be x squared. Now watch, distribute that in. X squared times that. X squared times this, everything cancels, but remember, bring down the 2x minus 1 because you got to distribute that negative. X squared times 1. X squared times this, and x cancels negative x. And boom, it looks so much better already. So x squared minus 2x plus 1, that could factor. I know the bottom can factor, so let's just do that. I factor the bottom, I factor the top, and what ends up happening here? And x minus 1 cancels, that's right. So x minus 1 over x. Not too bad? That's 15. And we may not get done. Look at 23. Said muffin after eating a bowl of sugar can cut an average yard in 3 hours. So what is her rate? 1/3 of a yard per hour. It takes Twinkle after a mere 2 tablespoons of sugar 5 hours to cut the same yard. What's her rate? 1/5 for each hour. It said, at what time will 2 of them be done cutting the yard if Muffin starts cutting the yard at 10 a.m.? So they're definitely cutting 1 yard. But wait, it said, and I could put the T's on the top if you want, but I've got to make one last adjustment. It says that Muffin begins cutting at 10 and Twinkle joins her at 11. So Twinkle did not cut it for the full allotment of time, did she? She started what? 1 hour later? So what would I have to do to her time?
Subtract 1 hour.
So she subtracted 1 hour from her time. And then you're ready to go. Now the question actually said, at what time will the 2 of them be finished? So I need to find how long it took and then add it back to 10 hours to see what time they're going to be done. All right? So what would you do to multiply, to solve this? 15 on the left, 15 on the right. So cancel, cancel, 5t. Cancel, cancel when you distribute that in. 3. All right? And then 3t minus 3. So 8t equals 18. T equals 18/8, which is 9/4, which is 2 1/4 hours. And what is 2 1/4 hours? 2 hours and 15 minutes. And remember, if you don't know what fraction of an hour, you just take 1/4 of 60 or whatever that fraction is times 60 to get the minutes. And then now I got to go back and I got to add it to 10. So I end up with 12, 15, what? Not a.m., but p.m. That's 23, 26. Okay, remember the trick to these in the video? It starts out not really being a trick. It starts out being, well, it says that find A and B that make that true. True means it's an identity. An identity means anything could work for X. Any value on the planet. Some people actually come in here and go, why don't you just plug 10 in for X and get an equation? You could do that. Why don't you just plug in 7 and get an equation? You could do that. Then you'd have 2 equations with 2 variables you could solve. But there's better ways to do that. So I'm going to kind of use this mentality, but check it out. You have an equation, so what do I know, especially since this factors into x minus 3x plus 2, what do I know I can do to make this look better? Multiply both sides by x minus 3x plus 2, because that's the common denominator. And if I multiply that on the left, what happens? Everything cancels. If I multiply it on the right, I got to distribute it in. And what happens when I distribute it in? A is left with the x plus 2, and B is left with an x minus 3. Now let me show you some magic. If I want, I could foil all that together and get a mess and start comparing the left and the right sides. Wait a minute. If this is true for any x, no matter what, why don't I just pick really clever x's? Like, what if I just said, let x equal -2? What happens if I plug a -2 right here where I'm pointing? A variable goes away. And all that's going to be left in that equation is a b and some numbers. Makes it really easy to solve for b. So check it out. -2 there gives me -4 minus 9. -2 there makes the a go away. Great. -2 there gives me -5b, right? So if -13 equals -5b, b equals 13/5. Sorry about that. I've got my b value. Is there another cleverly chosen number you could plug in? 3. If I plug a 3 in, 6 minus 9 is -3. 3 plus 2 is 5a, but 3 in there gives me 0b. That goes away. A is negative 3/5. And I just found my a and b. And I didn't have to do any crazy multiplying and comparing both sides. Y'all seeing that? That's 26. 27. This is probably the most missed question on my test last year. It's not on my test this year, but there's something maybe similar. But here's what people did almost always. They went, oh, if it's a negative exponent, I can move it down and make it a positive exponent. Negative exponent, I can move it up and make it a positive exponent. And they did that, and then everything was downhill. I can move it up and down if what? Do you remember me emphasizing this? I can move stuff up and down if it's being multiplied. That is totally u squared, v squared, u to the first v. That's true because it's being multiplied. But if it's being subtracted, I can't separate it. I have to just flip it right where it is. So really, this is not true. I would have to go, well, because that minus, I have to look at these as little isolated expressions. So that becomes what? And this becomes, oh, now I got a totally different looking problem, don't I? What would you do at this point? U squared, v squared? And look how nicely this changes everything real quickly. When I distribute it in, I get v squared minus a u squared. When I distribute that in, I get 1u cancels, so uv squared minus 1v cancels u squared v. And is there anything I can do at that point to simplify? I've done all PEMDAS I can do, but maybe if I factor it, it might divide. Let's see. I can factor the top, v minus u, v plus u, and I can take a uv out of the bottom, leaving me a v minus u. Oh, that does actually help, doesn't it? So v plus u over uv. But that would be the most simple I could do. 28, so our last one. I might want to have you, in fact, you know what? I want you to mess with that a little bit. I want you to, I'm not going to say suffer, but I want to see what you can do. So evidently I've thrown you a curveball, and I want to see what you can do, play around with this and get this. And, but remind me, well, if you want to, somebody at home, remind me to talk about, no, you'll all be here. Never mind, Thursday. Remind me to talk about 28 if you can't figure it out on Thursday. All right? All right, have I shown you all your seating arrangement?
Yeah.
I have?
Yeah.
Okay. I mean, I'll show you again.